Hi guys, David here with another science update. So today I want to talk about a couple articles that came across my feed this week that indicate that Europe, and particularly countries in the European Union, may actually be moving towards a more nuclear-friendly energy portfolio. And why I think that's interesting is because up to this point, there's been a lot of debate among scientists and among policymakers as to whether going nuclear is actually going green or not. So what we're going to do today is we're just going to briefly look at those news releases about what's going on in Europe in terms of energy policy, and then we're going to try to address the question of whether nuclear needs to have a place in our future energy portfolio. So the first article is entitled, Macron pushes nuclear hydrogen power in 30 billion euro plan to reverse industrial decline. And it says that President Emmanuel Macron said France would aim to become a leader in green hydrogen by 2030 and build new, smaller nuclear reactors as he unveiled a 5-year investment plan on Tuesday aimed at fostering industrial champions and innovation. And what's interesting about this is that in other articles I've seen that in recent years France has actually said that they want to reduce the amount of nuclear that they have in their energy portfolio, but this is actually kind of turning that around. They're talking about building new plants. And the other article that I saw is called Finland Lobbies Nuclear Energy as a Sustainable Source. And it says that wind and solar have been approved as sustainable by the EU, but decisions on gas and nuclear have so far not been made. Even if plants are emission-free, nuclear is currently considered only a low-carbon energy source due to emissions caused by mining and transport. Finland has 4 nuclear plants, and the 5th is nearing completion after years of postponements because of technical complexities. The future of nuclear energy remains important for the country. Its industry is highly energy-intensive, and Finland has a target of being carbon neutral by 2035. And currently, 30% of Finland's energy is produced by nuclear energy, which is a very high share, by the way. Because I don't think we're talking about total electricity, we're talking about total energy. So before diving into whether or not nuclear is actually a green technology, I want to talk briefly about the idea of a global energy portfolio, and also how that differs from a global electricity portfolio. And so I'm looking at data from ourworldanddata.org, /electricity mix, which I've included below if you're curious and want to look at these charts in more detail. But the first is actually to look at the mix of electricity in the world. And so you can see that oil, coal, and gas have large contributions, and these are the total fossil fuel production of electricity. And so fossil fuels actually contribute in 2020 to about 63% of global electrical production. And what's interesting, it says that in 2000, this was about 64%. So in 20 years of being aware of climate change, we've managed to reduce our fossil fuel contribution to electrical production by about 1%. And then wind and solar are about 5 and 3%. And then the total energy mix is different because this includes not just electricity, but it also includes transportation and heating fuel. And what's interesting is that there's even more fossil fuel contributions. So total fossil fuel production of energy share is actually about 84%. Nuclear is about 5%, and then wind and solar are 2% and 1%. So I think it's important to actually look at this data to kind of get a reality check. I think it's very easy to say that we need to invest heavily in wind and solar power, but we just need to recognize where we are right now. Right now, wind and solar, as part of the total energy mix, are just 3% of global production. That's a tiny sliver of this overall chart. And so we're talking about just absolutely massive increases in wind and solar, and we need to understand what that's going to take. And then the other factor to consider is that we all know that wind and solar are variable. And so what that means is if we were, for instance, mostly on wind and solar power, there will come a time when the wind will not blow and the sun will not shine on a particular day, and you'll see that amount of energy production just vary drastically. You're going to have a lot of brownouts and blackouts. So now that we've talked about that, let's actually talk about what is the carbon footprint of nuclear and other sources. And so there's this very useful chart here. This is taken from data from the Energy Institute's 2016 full cost of electricity study. This is from University of Texas. And what we hear is estimated levelized CO2 emissions. And so the x-axis shows levelized CO2 emissions, which is grams of CO2 equivalents per kilowatt hour. And this whole thing with the levelized CO2 is that they took into account the whole life cycle analysis. So people have argued that, okay, so nuclear doesn't really emit any carbon while it's operating, right? But it takes a lot of carbon to build a nuclear power plant. So that's what they took into account. But people also forget that a nuclear power plant can produce a lot of electricity. So what happens is you're going to actually normalize the carbon output associated with making the power plant over the total kilowatt hours of the lifetime of the nuclear power plant. And you can see here that, not really surprising, different types of coal actually produce the largest amount of CO2 per kilowatt hours. And then we have actually different forms of natural gas burning. NGCT here is a natural gas combustion turbine, and then NGCC is a natural gas combined cycle. So actually, if you, depending on what type of power plant you use, you can get a lot more energy out of natural gas for less carbon emissions. But still, that's not going to compare very favorably with things like photovoltaic cells, for instance. We see here it's much, much lower for photovoltaic would be solar cells, right? And then towards the bottom of the list is actually wind. So wind is actually one of the lowest carbon footprint technologies, and it's only being slightly beaten by nuclear. So at least according to this data, this is life cycle analysis, nuclear and wind power are estimated to have the lowest levelized CO2 emissions. So from the perspective of CO2 emissions, it looks like nuclear is actually the leader. So is nuclear going green? Well, at least from the point of view of carbon emissions, nuclear may be actually the greenest energy production technology we have. Now, people argue that there's a lot more to going green than just the carbon footprint, and they're absolutely right about that. You know, a lot of the times when it comes to optimizing things from an environmentalist point of view, sometimes you're in a position where you have to choose between, let's say, carbon emissions and plastic, right? So we know that plastic is harmful for the earth, but we also know that carbon emissions are harmful for the earth. Let me give you two scenarios, okay? Scenario one is, or the overall scenario is that you want to transport medicine from one side of the country to the other. And in the medicine, you need to have bottles. So the question is, will you use glass bottles or will you use plastic bottles? Which of these will be more friendly for the environment, right? Now, the glass bottles are heavier, right? And the plastic bottles are lighter. So since the glass bottles are heavier, if you have a truck full of glass bottles, that is heavier, and that actually takes more fossil fuel burning to get from one side of the country to the other. So your carbon emissions will actually be higher than if you transport your medicine in the plastic bottles, right? On the other hand, the plastic bottles might get thrown away after use, and then they could wind up in the ocean. So now you're going to have ocean plastic. So the question is, do you prioritize the importance of reducing CO2 emissions, or do you prioritize the importance of reducing plastic? They're mutually exclusive. So sometimes you have to pick a way to optimize. And my argument is that despite the fact that nuclear has some environmental downsides, the most important thing we need to optimize for right now is the carbon emissions. Right now, as a species, we're changing the chemical composition of the atmosphere. That is problem number one. That's the most important problem. We need to solve that problem, and then we can solve some other problems. That's my argument. So for instance, you know, people talk about the fact that with nuclear energy, we produce nuclear fuel. And that's true. And nuclear fuel is radioactive and it's dangerous. And it says the US generates about 2,000 metric tons of used fuel each year. But it also says, this article is from energy.gov, it says this number may sound like a lot, but it's actually quite small. In fact, the US has produced roughly 83,000 metric tons of used fuel since the 1950s, and all of it could fit on a single football field at a depth of less than 10 yards. And also, in the future, used fuel can be recycled, and we may be able to find more and more uses for used fuel. So, for instance, right now, Bill Gates is working on a nuclear power company, and they're trying to find ways to use spent nuclear fuel to make new power plants. And so the big question I would say is, when you're trying to optimize these scenarios where sometimes if you do one thing, it creates a problem, but if you do something else, it creates a different problem, you need to put a priority on which problems you're going to solve. So I don't really think there's a way to solve all the environmental problems at once. We need to pick one and solve it and then work on the other ones. So my argument is that we should solve the issue with climate change now. And we should solve it by going nuclear. And after we've solved that issue or put that on path for correction, then we need to put our attention towards figuring out more innovative ways to deal with nuclear waste. What it comes down to is I think that there are basically 3 scenarios for the future. Scenario 1 is that we keep on using fossil fuels a lot, and we have cheap, reliable energy, which is great, especially for the world's poor. And then we have really bad climate change. We have global warming, like 3 degrees, 4 degrees by 2100, and we have massive flooding and inundation of cities and coastal regions. Okay, that's scenario 1. Scenario 2 is that we go very, very heavy on renewable energy. And what happens is hopefully we're able to really expand capacity a lot, but we're still going to have this issue of this variable energy supply. And we're going to have a future with a lot of blackouts and brownouts, and we're going to have a lot of people, especially the world's poor, suffering because of that. On the other hand, if we really do that, we may in fact be able to massively reduce the amount of global warming, which is a very, very good thing, of course. And scenario 3 is where we massively invest in nuclear energy now, and we get reliable and affordable electricity for everyone in the world, and we reduce or slow global warming. So that's my approach. And I agree with what France is doing. I agree with what Finland and other countries are doing. I think we need to go nuclear, and by going nuclear, we're going to go green. Well, thanks so much for watching. I really appreciate the chance to share my opinion with you on this topic. And if you have a different point of view, please let me know in the comment section. Or if you agree with me, please let me know in the comment section. Like the video and subscribe. And I hope you'll join me again in the future soon. Bye.